Okay, hello, first period class. For the asynchronous time today, I want you to explore desmos.com/calculator. I will post that link in Canvas, but if you're already here, you probably have it. So what I want you to do is just explore this tool. I think that so far, other classes are telling me that they've been on this site before. And so I just want to make sure that you guys get the chance to explore it, and then we have 100% can experience it. So you're going to graph some inequalities and some equations. Let's start with an equation here. Now, if you go down to the bottom, let me just make sure this is full screen here. You go down to the bottom of the screen, in the lower left-hand corner is Keypad, and that will give you the opportunity to use the inequality signs. And then you can also use the square function, the absolute value function. Functions over here include sine and cosine. You don't need to do others. Sine and cosine will be what we will use when we look at trigonometric functions. That's later. If you want to explore that on your own, you're welcome to do so. But initially, you can just use your keypad, your keypad on your laptop or your computer and type in equations like y equals 2x subtract 3. And now you see that there's a line, and I can add another line by hitting enter. Oops. Enter, it gives me another row. I can type in an equation, say y equals a negative x, a negative slope of -1. And then let's shift this one up, 2, up 2. Okay, hit enter. And now I have a blue line highlighted when I'm inside that equation, red line highlighted when I'm inside that red equation, and then the intersection is a solution. Now, if this were a system of equations consisting of two conditions, a blue condition and a red condition, the condition such that y must be equal to 2x subtract 3, and a condition such that y must be equal to -x plus 2, when both conditions are satisfied at the same time, you have an intersection, which is this point right here. That means that the system has one solution. It also means that it is independent system. The two conditions don't depend on each other. These are independent. In an independent system, you're going to have one solution. Now, let me give you an example of a dependent system. A dependent system, if I were to take this equation, y equals 2x subtract 3, and I were to multiply both sides of the equation by 2, I would get 2y on one side. And then 2 times 2x is 4x. And then -3 times 2 is a -6. Now look what happens. I have two lines here, blue and red. They're mapped one on top of the other. These are dependent. They're also going to give you the same solutions for each equation. It gives you all of them the same solutions. This dependent system has infinitely many solutions. So that's the difference between dependent and independent. Dependent system, infinite solutions. Independent system, one solution. Both dependent and independent systems are consistent. A consistent system has at least one solution. Then you probably can figure out what inconsistent means. inconsistent system has no solution. So this is a consistent system. A system that has no solutions will be a set of equations that never cross. They don't touch anywhere. So how do I get two lines not to cross? That's right. They can have the same slope, but they're not going to be the same line. So I can type in y equals, use a slope of 2, and then instead of crossing the y-axis at -3, I'm going to have this one cross at a +2. Okay, here's a system that has no solution because these are parallel lines, they never cross. This system is inconsistent. No solution. Now, what happens if I change the equal signs to inequalities? I can do that with the keypad on the screen here. If I change the first equals to a less than, I get a shaded area that represents half the plane. This half plane is a solution for this inequality, the red inequality. Y is less than 2x subtract 3, but it's not equal to 2x subtract 3, which is the border. If I change this equal sign for the green component or condition, I'll show you two things here. If I shade above y is greater than, notice this is an inconsistent because there are no solutions that overlap. This is an inconsistent system of inequalities. If I change it to shading below, there is some overlap here. Again, the red overlaps with the green, and I get that gray area here. So this overlapping area, while it's a solution to the first inequality, is also the solution for the system. This area in here is not the solution for the system. It's only a solution for one part of it. Now notice what happens if I change the less than or equal to, less than to a less than or equal to. It changes the dashed line into a solid line. Now that means that what is on the line is included in this set of solutions. The dashed line indicates that the border is not a part of the solution set. This solid line means that the solution set includes that. Now, you'll see more like this. You'll see problems where one line has a different slope of another, and there's an intersection that looks like, it's an intersection of two half planes. Now I can throw in another equation here. Let's say y equals -2. And yeah, it's giving me a choice here. Let's say y is greater than -2. And now I have the intersection of three half planes. I have the green, I have the red, and I have the black. The overlapping area is a triangle, and this is the solution set for the system of three inequalities. This is also known as the feasible region. The feasible region of any system is that area where you can have all types of solutions that are feasible. So you could have a solution right here, right there. You could also have a solution that comes very close to the vertices of the triangle. But they wouldn't be the vertices of the triangle unless you also had solid lines that intersect. The fact that this green dashed line is not part of the solution set means that that vertex is not part of the solution set. So anything in here is going to be a solution. Any point in here will be a solution. to the system of 3 inequalities. Okay, so that has to do with graphing inequalities. And then I want to say that any assessment I give you with solving a system of inequalities is all going to be done by graphing. You're going to have watched this video. When you're done with this video, I want you to look at the other video I posted into Canvas. That will cover the material we did yesterday. And as I see a good review, it includes connecting solving multi-step equations with solving systems. And at the very end of that video, which is just 10 minutes, I want you to try a problem. You'll pause the video, attempt the problem, and then proceed to get your solution to see if you're correct. If you have any questions at all, you can email me, you can message me through Canvas. I'll be monitoring our Zoom room. You can log in that way. The links now work in Canvas. Those have been fixed. So I'll be waiting to check in with you guys once you finish both videos. If you have any questions, check in with me, or you can bring those questions to class tomorrow if you run out of time. I'm sorry, on Tuesday. Tomorrow will be ASL time as well. Okay, with that, I appreciate you guys signing on and watching, and I will see you later.